Alright, so mine was for pressure and PSI. So what is pressure? It's force over area. And as you can see, as the block on the left has a bigger area than the block on the right. And as a result, the pressure is smaller than the block on the right. And since area has a huge impact on the pressure, there's many ways that you can measure pressure. There's gauges, manometers. I'm sure if you're in thermodynamics, we've had a fun time with manometers, measuring different things. And then there's also barometers, which usually measure the atmospheric pressure. So what is measured in pressure? Air and gases are measured in pressure, liquids, and then loads on different things. And it's important that air and gases are measured in pressure because different air and gases have to be kept at certain pressures or else they can explode. And same goes for liquids. And then for loads, such as buildings, can only withstand certain amounts of pressure on structural components. So you don't want to overload certain structural components on buildings and other things so that they fail. And pressure also deals a lot with weather patterns. Whenever you get a high pressure system coming in, it's usually sunny weather, good weather. And when low pressure systems come in, they usually have rain and storms associated with them. And as a fisherman, you know as soon as that low pressure starts coming in, you want to hit the water. And as soon as it starts raining, then the barometric pressure goes way down, and the fish don't like that. So you want to get out there as soon as you see that barometric starting to fall, but not too low. So the unit I focused on was PSI, which is pounds per square inch, and this is an English measurement. And you can see 1 PSI is equal to 1 pound-foot over 1 inch squared, which is equal to 4.44 newtons per 0.0254 meters squared, which is then equal to 6,894 newton meters squared, which is known as a Pascal. So for my experiment, I chose 2 different types of board. One's 3-ply plywood and one's OSB. The picture on the right is the OSB, which is Orient strand board, and then you can see the board on the left is the plywood, and plywood is actually glued together with several sheets of wood. And you would think that the Orient strand board is just randomly placed, but it's actually placed in that order to make it the strongest. So I cut up the boards to 2-foot by 4-foot sections and then put them on top of a sawhorse, and I marked the center of gravity on each one, and then placed weights on the boards until they broke. And as you can see, the load is my P, and it was on the center of the board, so I couldn't directly measure the pressure since it was just a load straight down on the board, which isn't evenly distributed across the whole board. So I had to go talk to Prof. Young and review some of my statics, and the graph below there is that is the load graph, and you can find the area of each one to get the loads, and then the one below that's the moment graph, and the moment's the greatest in the middle, so that's why it's PL over 4 right in the middle there. And from using both those graphs, you can find the bending stress, which is MC over I, and the M is the moment, and C is the distance from the middle of the board to the end where the sawhorses were. And then I changes for different shapes. So I, for this one, was a rectangle, which turned out to be 1/12 times the base times the height. And for the plywood, I ended up getting 60 pounds and 95 pounds. And for the OSB, I got 250 pounds and 337 pounds. So you can already see that the OSB was holding a lot more weight than the plywood. And I could calculate the PSI on the board just in the area of the size of the weight that was on there. So I calculated the PSI for each one. And then I used Excel to help me calculate the bending stress of each one. And you can see on the bottom right corner that the plywood had a far less bending stress than the OSB board. So in conclusion, with the increase in pressure, we saw an increase in bending stress, and where the pressure is actually placed impacts the end results. And OSB board was far better than the 3-ply plywood and sustained more force and bending stress.